So the last thing we're going to do in this unit is I'm going to graph secant and cosecant. So we're going to complete this table, and if you've been paying attention, all the values for sine are between -1 and 1. So completing this table, sine of 0 is 0, pi over 6 is a half, pi over 4 is radical 2 over 2, this is radical 3 over 2, this is 0, 1/2, 0, -1 and 0. When I complete this table, I'm not doing the whole unit circle, just some key points. And how do I figure out cosecant? Well, cosecant of x is equal to 1 over sine of x, the reciprocal. So when I want to do these values, I'm going to take these reciprocals. So 1 over 0's reciprocal is undefined. 1/2's reciprocal is 2. I get 2 over radical 2, but I said that's just radical 2. 2 over radical 3, undefined. 2, undefined. -1 and undefined. So these are the values for cosecant that I'm going to graph. So my question is, how am I going to do this? Well, what I'm really going to do, I'm going to graph y equals sine of x to draw y equals cosecant of x. I have some values here that are undefined, as you see. So how do I graph undefined? Those are just going to be vertical asymptotes. So first thing I'm going to do is graph sine of x. I'm going to do that in gray. So sine of x goes middle, max, middle, mid, middle. And right now, in this light gray, this is the sine of x graph. Okay, and what I'm going to do is take the reciprocals of all these values. So here's a key. All x-intercepts of the dots on the midline, in this case, on y equals sine of x, they become the vertical asymptotes. So these dots here that are the x-intercepts, or the points that are on the midline, more importantly, the ones that are on the midline, they become the vertical asymptotes. I'm only going to use a pattern. If you notice the pattern right now, it's always going to be n times whatever the first tick mark is. If I look carefully at this pattern, the first tick mark is this, so it's going to be n times pi over 2. If I notice, I have vertical asymptotes down the middle at the second square, on the fourth square, on the negative second square, on the negative fourth square. So that means I have an even pattern of, vertical asymptotes. But what I need to do is take this gray bump that's all above the x-axis, all positive numbers, and flip it the other way around. Well, this number right here, y value is 1, and this y value here is a half. I have to take the reciprocals. So this one becomes 1, this becomes 2, this one also becomes 2. You get these little U-shaped, not parabolas because they're stuck between asymptotes, but there's a U-shaped graph. So this point here at -1 stays at -1, becomes these U-shapes. You get these U-shapes. And they kind of alternate. An upper U, a lower U, an upper U, a lower U. My domain is not all real numbers. It's all real numbers except these vertical asymptotes. Can't use those guys. My zeros are my x-intercepts. There are none. My range is two parts, -infinity to -1, together with 1 to infinity. This is the lower part. This is the upper part. My period for this graph is still 2 pi, because it still takes 4 squares. And my symmetry is odd, because sine is an odd graph. Okay. And it takes 4 squares to get a period. So I'm taking the waves of y equals sine of x, and they get flipped and I get these U shapes, one upper, one lower, and that's what's going to happen. I'm taking all the waves and flipping them into these U's. Well, let's do the same thing with cosine. So all these values for cosine of an angle is between -1 and 1, and we get these values from our unit circle that we've done before. Those are the cosine values. So how do I get secant? Well, secant is just the reciprocal of cosine. So I'm taking all these values in blue and turning them upside down. 1 becomes 1, 2 a radical 3, 2 a radical 2 is just a radical 2, 2, undefined, 2, -1, undefined, and 1. So I'm going to graph these values. Again, how do I graph undefined? They become vertical asymptotes. My pattern for my vertical asymptotes is always going to be n times whatever the first tick mark is, and then I have to decide, is that the even or the odd squares after the y-axis? Because once you set it up, every other square on the x-axis or every other grid on the x-axis is going to be a vertical asymptote. I'm going to roll the cosine wave. So I'm going to graph y equals cosine of x to draw y equals secant of x. So the cosine graph goes max, middle, min, middle, max, middle, min, middle, max. And I get this graph like this. And again, all the x-intercepts or the midlines become the VAs, and so I have one here, here, and if you notice, every other dot that was an x-intercept or on the midline becomes the VAs. And this gray bump that's above the x-axis, 1 stays 1, it becomes a U. The one below becomes an upside down U. And this one, I'm going to go off the graph a little bit just because I know it should be a U. And this side I'm going to get the same thing. And like I said, what we did before, the waves of y equals cosine of x, they get flipped as these U's. So let's do my vertical asymptotes. This would be n times whatever the first tick mark is. The first tick mark is pi over 2, and I have to decide, is it even or odd? Well, if I go from here to the first asymptote, it's 1 square away. And it's 3 squares away, and it's -1 square away, it's a -3 squares away. These are all odd numbers. My domain is all real numbers except for my VAs. Those are missing. There are no x-intercepts. My range is exactly what we had before. A lower part and an upper part. My period is still 2 pi, just like cosine, because it takes 4 squares. My symmetry is even, just like the cosine graph. So when I draw secant and cosecant graphs, I actually draw sine and cosine graphs first, and I just take what I have and I flip them around. Okay, we're going to do the same 4 letters that we did with the other graphs, except they're not always the same because of what we have. A is a vertical stretch or compression for any graph, but secant and cosecants do not have amplitudes. What it is, though, I use the A value to graph my sine and cosine graph because that gives me my mins and maxes, and then I can make my U's. D is a shift up or down. It will not be the midline for this graph because secant and cosecant graphs are not sine and cosine waves. They don't have midlines. But I'm going to use D to graph sine and cosine because all the points on the midline, they become the VAs. This is a horizontal stretch or compression. I'm still going to use my period is equal to, I'll write out the word period, 2 pi over b. Yeah. Period equals 2 pi over b, or 2 pi times 1 over b. And this is a shift left or right. And I will use my phase shift is equal to negative c over b, or negative c times 1 over b, whichever you prefer. But really what I'm going to do is draw the sine and cosine graph before I draw a secant or cosecant graph. So because it's secant, I'm actually going to draw a cosine graph. And it's going to be a negative cosine graph, which means I start at the minimum. I'm going to go up from there. I see the letters A, B, and D. And D is my midline at negative 1. I'm going to draw it very lightly. My amplitude is 2. So I'm going to go up 2 and down 2 from this. There's no phase shift, so my first thought is going to be on the minimum right here. I'm going to draw my little cosine graph. And here is my cosine graph that I'm drawing. Because I'm really drawing y equals negative 2 cosine of 4x minus 1. I haven't labeled the x-axis yet. I'm going to do that now. I know I have to do my period as 2 pi over b, and I get 2 pi over 4, which is pi over 2. I'm going to set that up as my 4th tick mark. 1, 2, 3, 4 is pi over 2. I do 1/4 times pi over 2. I get pi over 8. So it's 1 pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. And then all the dots on the midline, these red dots, it's going to be every other point. Every other point is going to be on the midline. These become the VAs. You see right here, every other square on the x-axis is getting a red vertical line because those are all the VAs. And my vertical asymptote is always going to be n times the first tick mark. In this case, it's going to be n times pi over 8 because that's the first tick mark. And if I notice, if I start at the origin, my first tick mark is 1 square away from the origin, so that as n equals an odd number. My domain is all real numbers except for the VAs. And let me draw this graph. I'm going to draw it in, I'll draw it in blue. See this gray bump above the midline? I'm going to make it into a positive view. This one below, I'm going to make it into a negative view. Notice the mins and maxes do not move. So this min stays the same. This max stays the same. This min stays the same. And this is what I get. Now when I want to do my range, I'll do that in pink. I have a lower, negative infinity to negative 3, in union with the upper is from 1 to infinity. In symmetry, I could fold it over the y-axis, so this has even symmetry. So that is the graph of this negative 2 secant 4x minus 1. So this last one, I have my a, b, c, and d values. B is equal to 1. Cosecant means it's a sine graph. The midline of the sine graph is at 2. I'll draw that right here. Just help me out. I'm going to mark my min and my max by my amplitude of 3. So I have to go up 3 and down 3. This is a sine graph, so the first dot is going to be on the midline. I'm going to go up from there. So that's my first dot. My period is going to be 2 pi over b, which is just 2 pi over 1. So the fourth tick mark is equal to 2 pi. 1, 2, 3, 4. It's 2 pi. I do a fourth of that. I get pi over 2 is the first tick mark. So it goes 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. There is a phase shift, so I need to pay attention to this phase shift. My phase shift, how I have to move that first dot is going to be the negative c over b, so it's going to be positive pi over 1. That's mean I have to move it 2 squares to the right. So this first dot is moved 2 squares to the right. So this is really the first dot. I'm going to draw the rest in gray. So my first dot goes up to the max, middle, goes to the min, middle, max, middle, min, middle. I get this graph. This is the sine graph that I'm going to use to draw my cosecant graph. So all the dots on the midline, 1. All the dots on the midline, 1, 2, 3, 4, these 5 are going to be the VAs I'm drawing in red. Okay, and I know I'm going to go off the graph a little bit, but it doesn't really matter. Well, let me do the VAs. I'm always going to do n times the first tick mark. In this case, it's going to be n times the first tick mark is pi over 2. And I notice it's in the middle. It's 2 squares away. It's 4 squares away. That is an even number of squares. So this blue arch here gets flipped. This point stays the same. And it's going to be, I know it's off the graph. That's okay. It's up here. These are below it. Here's that minimum value. And there's that upside down U. Here's that upside down U. And my domain will always be all real numbers except for the VAs. And my range for this one, if you notice, the lower goes from negative infinity to negative 1 in union with, I know it's off the graph, but 5 to infinity. And my symmetry, man, it looks like it's a flipped upside down picture. It actually is no symmetry. None. It is almost odd. It's very close to odd, but up to ruined that. If it wasn't up 2, it would be an odd graph. If I took that same graph and moved it down to where the midline was at 0, it would be an odd graph, but it's not odd because of that up 2. Thank you for watching this video.